Hello, we are going to be doing lesson 7.4 from the Pre-Calculus Part 2 part of the book. This is on page 770. It happens to be example 3 in your textbook. And what we're doing here is what we've done in previous terms with linear equations. We're going to show you that this also can work for non-linear systems of equations. Now, I don't know if you recognize or not, but the top one here is the equation of an ellipse, and the bottom one here is the equation of a circle. Now, one of the ways that we could do this is actually graphing and then seeing where that ellipse crosses that circle, and the places where they cross would be the solutions to this. But this particular method is trying to show you that you could do it by what this particular book calls the addition method. Sometimes I call this the elimination method because you're going to end up eliminating either the x or the y variable in order to solve. So in step 1, you're going to write both equations in the form of ax squared plus by squared plus c. However, in this particular problem, both of these are already in that form, so we can skip this step. Step 2, if it's necessary, you're going to multiply one or both equations by an appropriate number so that when you add the two, either the y values or the x values together, that they're going to eliminate each other. Now, in looking at this problem, since both of these are y squared, if I would just multiply the bottom one by a negative to make it opposite, then it would be very easy to eliminate my y squared. So that's what we're going to do. Notice the top equation here. There is no change. We keep it 4x squared plus y squared equals 13. However, on the bottom, we're going to multiply the entire equation here by -1. Which gives me negative x squared minus y squared minus equals minus or -10. Okay. Now, when you add these equations together, which is, we're taking the new one here, when you add these two equations together, 4x squared plus negative x squared becomes 3x squared. And the y squareds, because they're opposites, they just completely disappear, or what we call the elimination method. They eliminate each other. And then finally, we have 13 plus -10, which ends up being a +3. Now, if I divide both sides by 3's, I'll get x squared by itself, and that is equal to 1. And of course, when you take the square root of x, you're going to get both +1 and -1. Okay, now that's important. Some things you can't have negative, but on these you can, because you can have a -1 as a point. So we have two x values here. X could be +1 or x could be -1. Now, step 5 is, now that we know x, we're going to substitute that back in to one of the two original formulas or equations, and then we're going to solve for the y value. Now, in this particular example, they have chosen the first one, the x squared plus y squared equals 10. So that's what you see right here, except for instead of x, they're putting in +1. Now, if you put in +1 here, you're going to end up with 1 squared is still just 1. If I subtract that over to the other side, I'm going to get 9. So if y squared equals 9, then y equals ±3. So that means when I put 1 in, +1 in, I'm going to get 3. I'm also going to get -3. Okay. However, what do we do if x had been -1? Well, again, plug it into the equation, substitute it in. -1 squared plus y squared equals 10. -1 squared is still 1. So when I subtract the 1 from the 10, I still get 9. So again, y is still ±3. What does that mean? It means that even when we put -1 in for the x value, we're going to get a 3, or if we put a -1 in, we could get a -3. So there actually ends up being 4 solutions. The +1 gave you a +3, or the +1 gave you a -3. as well as the negative 1 gave you a positive 3, and the negative 1 also gave you a negative 3. So you end up with 4 places. That means, and again, the graph, you do not have to graph this. It's just trying to show you visually that the blue one is the equation of 4x squared plus y squared equals the 13, and the purple circle here was the x squared plus y squared equals 10, which was a circle. If these were graphed, and it is here so that you can see that, you'll see that they really do cross at negative 1, 3, positive 1, 3, negative 1, negative 3, and positive 1, negative 3. So they do cross at those 4 places that we found mathematically. I hope this is helpful.